Let's see some of the important problems on the sample size. If you like my content, please do subscribe to my channel. So here we go with the first problem. It is desired to estimate the mean time of continuous until an answering machine will first require service. If it can be assumed that sigma is equals to 60 days, how large a sample is needed so that one will be able to assert with 90% confidence that the sample mean is off by at most 10 days. So here we have to find out the sample size. So here you can see how large a sample is needed, nothing but the sample size we have to find out. The given information is the sigma value is given as 60 and the 90% confidence, and you can see a statement that the sample mean is off by at most 10 days, nothing but the maximum error is 10 days. So whenever you can see the sample mean is off by, then you can understand that the value which is given is the maximum error. So in previous video we have solved some problems on how to find out the maximum error from the given information. So we was having a formula E is equals to Z alpha by 2 into sigma by N. So here also the same. The sample size we have to find out. First write the given information. So the maximum error is given as E is equals to 10 days and sigma is equals to 60 days. So for 90% confidence, the Z alpha by 2 is equals to 1.645. So this is the standard Z alpha by 2 value for 90% confidence. Just you have to remember this value. It is 1.645. Now the formula is to find out the sample size is N is equals to Z alpha by 2 into sigma by E whole square. So previously we was having a formula for maximum error. E is equals to Z alpha by 2 into sigma by root n. So now we need this, we have to find out that we have to get the formula for n. So for that, so this can also be written as E into Z alpha by 2 into sigma by root n. Now by cross multiplying this, we can get root n is equals to Z alpha by 2 into sigma by E. Now we just need to get only n. So by squaring on both sides, or you can send this root onto the right hand side, so it becomes square. So that will get it as n is equals to Z alpha by 2 into sigma by E whole square. So we are sending this square root onto the right hand side, so it becomes the square. So now this is the formula to find out the sample size. Now n is equals to Z alpha by 2 into sigma by E whole square. So that is equals to, substitute all the values here. Z alpha by 2 is 1.645 into the sigma is 60 divided by the maximum error is 10 whole square. So this value we get it as 97.41. So the sample size will be an integer value. So approximately this value we can take it as 97. So therefore the n value is equals to 97. It means the sample size is 97. So here you can see that how large a sample is needed. So it's indirectly saying that the sample size is a large sample. So large sample nothing but the n value will be greater than 30. So final value what we got, it is 97. So it is also greater than 30. So whenever you find that sample mean is off by at most, if any value is given here, then you can treat that as the maximum error. So this is how we solve the sample size problems. So the second problem we are having, the dean of a college wants to use the mean of a random sample to estimate the average amount of time students take to get from one class to the next class, and she wants to able to assert with 99% confidence that the error is at most 0.25 minutes. If it can be experiment that sigma is equals to 1.440 minutes, how large a sample will she have to take? So here so random sample to estimate that average amount of time required by the students to take to get from one class to the another class. So that he or she wants to calculate it. then she wants to able to assert with 99% confidence. So the confidence is given as 99% and the maximum error is given as 0.25 and the sigma standard deviation is given as 1.40. So we have to find out how large a sample will she have to take. Nothing but the sample size n we have to find out. So all the given information is there. Z alpha by 2 we can calculate. Then for 99% confidence, the Z alpha by 2 value is 2.57 and the E is equals to 0.25, sigma is equals to 1.40. So these three values we can substitute in the formula, then we can get the sample size n. So first write the given information. So the question E seems to like it is very big, but just the values you have to find out, and first when you write the given information and the formula which you have to use, then the answer can be get easily. So just you have to understand whatever the values are given from the problem and just you need to check what we have to find out. So based on that you can use the formula and all the required values can be applied in the formula to get the value. So the first write the information. E is equals to 0.25 which is a maximum error and the standard deviation sigma is equals to 1.40 and for 99% confidence the Z alpha by 2 value is given as 2.57. So this is a standard value, you just need to remember this. Now the formula we know n is equals to Z alpha by 2 into sigma by E whole square. So just substitute the values. N is equals to 2.57 into the sigma is 1.40 divided by E is 0.25 and whole square. So this value we get it as 207.129. So the sample size cannot be in decimal point. So just approximate value you have to take. So this is approximate to 207. So therefore the sample size n is equals to 207. So in the question itself you can understand how large a sample will she have to take. So they indirectly they are saying that sample size is a large. Then after getting a sample size it is 207. So it is greater than 30. So you can say it is a large sample. So question is somewhat big but the answer is very easy. So the third problem is if we can assert with 95% that the maximum error is 0.05 and p is equals to 0.2, find the size of sample. So this problem is somewhat different because the maximum error formula we will use is somewhat different. So first let's understand the what is given in the problem. 95% of confidence and the maximum error is 0.05, E is equals to 0.05 and the p value is given as 0.2. So p nothing but it is in a population proportion that is denoted by p. So that is given as 0.2. Now find the size of the sample, nothing but sample size n we have to find out. So first write the given information. Given E is equals to 0.05. So for 95% confidence the Z alpha by 2 is given as 1.96. This is a standard value, you just need to remember this. Now we know that p plus q is equals to 1 and the p value is given as 0.2. So next we have to find out the q value also. So sum of the probabilities is equals to the 1. Now from this q is equals to 1 minus p. I am sending this plus p onto the right hand side, so it becomes minus p. Now q is equals to 1 minus p. So in this substitute the value of p and also given that p is equals to 0.2. So n value we have to find out. Then next 1 minus 0.2 is equals to 0.8. Now q is equals to 0.8. So p value we know, q value we know and e value also we know. Then z alpha by 2 is equals to 1.96. So now the main formula is E is equals to Z alpha by 2 into square root of PQ by N. So previously we have seen the formula is E is equals to Z alpha by 2 into sigma by root n. So that formula we have seen because in the problem if the standard deviation is given then we can use that formula. But here the standard deviation value is not given. The value of p is given. So from that, just from the given information which is provided in the problem, by seeing that we have to use the formula. So this is one of the important formula, z alpha by 2 into root pq by n. So in upcoming session also we will solve some of the problems uh, related to uh, this this formula. So now z alpha by 2 into root of pq by root n. So I am writing this root. So this root is for both numerator and denominator. So when I write this separately, root pq by root n. So the root ab, root of a by b can be written as root a by root b. So that root can be written separately for the numerator as well as for the denominator. So root z alpha by 2 into root pq by root n. Now as we need the n value, so send this on to the right hand side. It means just we are cross multiplying this. Now it becomes root n is equals to z alpha by 2 into root pq divided by the e. So that is equals to z alpha by 2 by e whole square and pq. So just we are squaring here. By squaring this, so this square root will get cancelled, so that it becomes pq, and here for this it becomes this square. Just we are squaring here. Now the root n is equals to, substitute the values, 1.96 into root of 0.6 into 0.8. Just no need to write this, directly you can substitute the values here. Even if you do like this, then you will also get the same answer, but you will be getting confused. So just directly substitute the values here. So z alpha by 2 is 1.96 into the root of p into q, nothing but 0.2 into 0.8. Sorry, it is 0.2 into 0.8, and then divided by the e value is 0.05. Now the 0.2 into 0.8 is 0.16. So 1.96 into root of 0.16 divided by the 0.05. Now that value comes as 15.68. So root n is equals to 15.68. Now then n is equals to 15.68 whole square, because I want only the value of n. So I am sending this square root onto the right hand side. So it becomes this square. N is equals to 15.68 whole square. This value I get it as 245.862. So as n value cannot be in decimal point, so we just have to approximate to the integer value. So as it is 2.5 above, it is 245.862. So this is greater than 245.5. This is greater than 245.5. So just we have to approximate up to the 246. As it is greater than 245.5, then we have to approximate it to the 246. So therefore the n value, nothing but the sample size, is 246. So this formula is very important. Based on the information provided in the problem, we have to use the formula. So the final problem on the sample size is, what is the size of the smallest sample required to estimate an unknown population to within a maximum error of 0.06 with at least 95% confidence. So maximum error is given as 0.06, and for 95% confidence the z alpha by 2 is equals to 1.96. So this is the value for the z alpha by 2, and so whenever the population proportion is not given, so we have to take it as 1 by 2. So p and q, that is 1 by 2 and the 1 by 2. So when you add, so the formula is 1 by p plus q is equals to 1. So when you add 1 by 2 and plus 1 by 2, you will get it as 1. So we are equally proporting to the p and q. So if it is not mentioned in the problem p value, then you have to take it as 1 by 2 and the q as 1 by 2. So directly you can write a formula, that is E is equals to 1 by 4 into z alpha by 2 by root n. Or for n, you can write it as n is equals to 1.4 into z alpha by 2 e whole square. So this formula you can use to find out this the sample size whenever the p value is not given in the problem. So they didn't give the sigma value, they didn't even give the p value. So at that time you can use this formula. So 1 by 4 nothing but we are by when I apply in this formula p into q 1 by 2 into 1 by 2, so it gives us 1 by 4. So directly if you remember this formula, then you can apply the values for z alpha by 2 and e. So n is equals to, now apply all the values here. 1.96 divided by 0.06 whole square into p is 1 by 2 and the q is 1 by 2. So n is equals to 1.96 whole square divided by 0.06 whole square, and in the numerator 1 into 1, denominator 2 into 2 is 4. So this value we get it as 266.77. So n is equals to 260.77. As we know that the sample size cannot be in decimal points, so we have to approximate it to the integer. Now 266.77, this is, as it is above the 266.5, then we will approximate to the 267. So it is approximately equal to the 267, therefore n is equals to 267. So this z alpha by 2 value, you have to remember 1.96. If you don't remember, then you will be having a very big process. So here the 95% confidence given, so then alpha will be 5%. It means 100% minus 95%, which gives the 5%. So now alpha will be 5%. As we have to calculate the alpha by 2, now when I calculate alpha by 2, that is 5% divided by 2, which gives me 0.025. Now again from the z table we have to calculate the area. From that we will get the value, that is 1.96. So it will be a very big process. So it is a small value, you can just remember this. So 95% confidence, the z value will be given as 1.96. Now this is a way to solve. So this formula is one of the important. Whenever in a problem they didn't mention the standard deviation value or the population proportion value, then at the time you can use this formula directly. So this 1.4 nothing but it is p into q. So p into q nothing but we are just equalating, when we add p plus q is equals to 1, so we have to divide the value 1 equally to the p as well as equally to the q. So at that time the only one and only value is 1 by 2 for both the p and q. So this 1 by 2 is a value which is equal for p and q. We are equally dividing the 1. So that value is 1 by 2. Now when I multiply 1 by 2 into 1 by 2, it gives me the 1 by 4. So directly this formula you can remember. And whenever in the problem they didn't give the sigma value or the population proportion value, then at that time directly you can use this formula. So this is about the sample size problems. Let's see some other problems on this. These are some of the extra problems. You just solve it by your own. The question seems like it is big, but the answer will be very easy. So the first problem, it is designed to estimate the mean number of hours of continuous use until a certain computer will first require repairs. If it can be assumed that sigma is equals to 48 hours, how large a sample be needed so that one will be able to assert with 90% confidence that the sample mean is off by at most 10 hours. Same like the previous, this type of problem we have already solved. The sigma is given, 90% confidence is given, and the sample is off by at most 10 hours nothing but the e value is equals to 10 hours. So sigma given as 48 and it is 90% confidence. So z alpha by 2 you have to get the value. Then when you substitute in the formula you will get n is equals to 62. So the same process we will proceed. Now the second problem, to estimate the average amount of time visitors take to move from one building to the another. So this type of problem similar to this we have seen. Students move, take time, how much time did the students take to move from one class to the another class. So here also the same, average amount of time visitors take to move from one building to the another in an office complex. The mean of a random sample of size is used. So given sigma is equals to 1.40 minutes, determine how large should be the sample size if it is as certain with 99% confidence that the error E is at most 0.25. So E is 0.25, 99% confidence, then Z alpha by 2 value you have to get, and sigma given as 1.40. So you have to calculate the value for N. So another problem, the research worker wants to determine the average time it takes a machine to rotate line thirds of a car, and he wants to be able to assert with 95% confidence that the mean of sample off by at most 0.5 minutes. So sample off by at most the 0.5 minutes nothing but the maximum error is equals to 0.5. If we can pressure from past experience that sigma is equals to 1.6 minutes, how large a sample will he have to take? So here the 95% confidence, and then the 1.6 minutes is given. So this is presume. So sigma is 1.6 minutes and n value we have to find out, and also given that 95% confidence. Sorry, it is 95% confidence. So based on this information, the value of n we have to find out. So this is about on how to solve the sample size related problems. And if you have any doubts, then let me know in the comment section.